cover here. I spent about 20 of the last years working with large organisations, governments, Sydney Festival is one of my clients for the last 4 years, basically applying technology to business problems in a human way. So how do we empathise with our customers in the digital space seems to be a real mystery, yet when we do it face to face it's really obvious. So that's a lot of where I've spent my time, and kind of this is how I've been for the last 20 years. But that's all about to change in terms of my attire, because I've discovered something that's lit that spark again in my eyes. So I'm going to be covering what happens when the open source movement meets hardware, radically rapid prototyping with relation to drone development, what are the technology enablers for this technology and I think lots of other problem-solving situations, and what are the community enablers as well, because they're super important. As a definition, the maker movement is essentially the web generation, so a lot of us in the room, creating physical things from bits, from data bits, and the portability that enables as well, when you can send a file anywhere in the world and have something made. Now, a great resource for this is a book by Chris Anderson, who was the editor-in-chief of Wired magazine. He also wrote The Long Tail, and he's just written Makers, and in fact left Wired to pursue a drone business. I'm sort of following a little bit in his footsteps, but not quite. So the open source software movement, I think a lot of people think of it like this. And the best definition for business I've heard is there are two parts to business. You create value and you capture value. I think this guy's doing an awesome job at creating value, but this guy, he's capturing value. It's a really funny video, you have to watch it. So what are some of the companies that are capturing value from the open source movement? There's some really surprising ones. So Firefox, in that search box up in the top, whenever you do a search, it always goes to Google by default. And Google pays Firefox $300 million a year for that privilege. It was a $1 billion deal for 3 years. Linux, which powers most of the internet we enjoy, generates $1.3 billion a year in subscription support services. One of the biggest users of Linux is, in fact, our favourite, Facebook. They have currently, it's estimated, 180,000 servers. If you were to pay Microsoft $500 per server license, which is the current fee for a base level server, you're clocking up some serious license fees. So a lot of things wouldn't be possible without the open source movement that we enjoy today. So what is open source hardware like? There's a fantastic video that does much better justice than I could. It takes a couple of minutes, and it's by a new organisation. This is probably about a week or so old, the Open Source Hardware Association.
What is open source hardware? It's a physical item whose source files have been shared openly with the world and can be freely copied or modified. In the open world, it's not about reinventing the wheel. Anyone can improve and build upon the ideas of those around them, and innovation is accelerated through the open exchange of ideas. Rather than starting from scratch, open source hardware allows you to modify a design for your own project or even turn it into a business. In 1817, a two-wheeled machine called a draisine was invented. It was made entirely of wood, propelled by walking, and designed to ease travel across the royal gardens. But because people saw hundreds of ways to make that machine work for them, over the past 200 years they modified the prototype, adding useful things like pedals, rubber tires, gears, chains, and durable metal frames. Over time, our international community took a simple machine's original design, shared their ideas, and customized the modern bicycle to suit the needs of 1.4 billion people around the world. This collaboration is what the open source movement is all about, and its ideology has the potential to shape the future of how our society does business. In a world fueled by open contribution, companies can no longer rest on intellectual property. This allows the open source hardware world to quickly find the most efficient and fastest producers for physical goods. On a level playing field strengthened by community input, companies will be distinguished by their adaptability and the quality of their products. By opening progress to the public, we put the catalyst for positive change in the hands of those who care about it most, and we can begin to see innovation driven by passion and equality. That's where we come in. The Open Source Hardware Association recognizes a need to improve the way we work together to revitalize collaboration at home and around the world. We want to show people that sharing ideas makes for better ones, and that open source is a smart and sustainable path to a stronger, happier community. What will you share?
Isn't that great? I just love the example of a bicycle being an open source bit of hardware that 1.4 billion people get utility from. And I think the broader philosophy here that's really important to me is that if we pursue creating economic opportunity for as many people as possible, that's how we ensure our security at home, as a country, and around the world. And I think that's something we need to pursue. And let's have a look at some of the ways that this can happen. Now, in Chris's book, he talks about all of the promises of the digital economy revolutionizing manufacturing, well, not so much manufacturing, but the way we live and work. In most developed countries, the digital economy still only accounts for 10% of the GDP. The other 90% are all the physical things we still buy and ship around. So this is what I'm talking about, what happens when we start really innovating through open source in the physical world. Rapid prototyping. I've got some props, these are awesome. So this could not have existed a few years ago. The sensors were too big, processing wasn't fast enough. When I talk about rapid prototyping, you might think of 3D printing, and they certainly play a role in this world. But this is a speed of prototyping that's a bit faster. And I'm going to talk about drones, not these ones, more like these ones. So these are things that you can build yourself and fly reasonably safely. This is where it started. So if I go back, that little controller, the little green thing on top, a few years ago looked like this. This is what was hacked together by Chris Anderson and some of his community. So there's a little controller, which is from Lego. There's that big grey thing, a gyroscope sensor, a prototyping board, an Arduino, which we'll talk a little bit more about, and a servo controller. That's what controls the motors, and an external GPS. So it's big and heavy, but it got people going. And a big part of the open source movement was online community, and it's exactly the same in hardware. So you can bring together the best minds in the world to work on an idea. And you contrast that to a company which headquarters itself somewhere and expects to get the best talent that happens to live within a 20-kilometre radius. It's just a totally different thing. So over the next few years, the community iterated, they built on each other's work, it's all open source, all of the designs are available, and this is what they've produced today. It's the Arducopter Pilot, and that's it here. It's the brain, and it can actually fly autonomously. So I can bring up a Google map and say, go here, go here, go here, point the camera in this direction, and I've got some pretty amazing footage. And all of those things have been shrunk down. This is in a matter of a few years. He's, in fact, started, one of the things that happened in the community was that people said, well, we don't want to build our circuit boards ourselves, so why don't you do it for us? And he started making these with his kids at home, and then had to start a company and found a CEO from the community to run that company, and then left Wired less than a year ago to run this multi-million-dollar company now. And I think about a month ago, a senator stood up in Congress and said by 2020 there will be 30,000 of these drones in the skies over the US. And Chris responded with an article saying, actually we sell 30,000 of these a year already. So it's just like the internet, it's gotten away from government control, if you like. And not only are they building the brains, they're building the quadcopters, the finished quadcopters. So the community demanded a commercial output of all of this effort, and no one resents 3D robotics delivering and making a profit from everyone's work. Here's another really interesting thing. This just happened in the last week. It's gotten the DIY drones community in a real tiz, because Hobby King is a Hong Kong-based manufacturer, and they've copied it. It looks like they've copied it. Everyone's really upset, and they're selling it not for $180, they're selling it for $70. They did misstep, they called it the same thing, it was a trademark name for 3D robotics, but they actually have the rights to manufacture this, and that's one of the massive enablers, because at $70, a lot more people can get into the sport or this area. And I think it's that growing the pie concept that these guys are really promulgating. But it's interesting how the community resists that, because they're very protective. So we've seen that one. This one is pretty amazing. I love the concept that things that couldn't exist a few years ago now exist. So this is a nanocopter. It's got a lot of the same technology as that one does. It didn't exist up until about 3 months ago. It also happens to have a camera on there. Yep, turn it on. I'm not going to fly it, but I'll just show you. I'm on film. But the amazing thing is, it's called FPV, first person view. So it's transmitting a live signal to the controller so I can see what this sees. So you might be able to see there.
Wow.
$200. Now, if I was in a SWAT team, I would buy this out of my own pocket. It's just amazing. And if you just want to lightly... Oh, sure, I'll just do it.
What do I do?
Oh, no, it's not connecting to each other. That's all right.
Okay.
But we might do an outdoor demo later. All right. But here's a video I prepared earlier. So this is flying a quadcopter, which has got 4 rotors.
Ian, tell us what happened to the quadcopter. Why?
Don't know.
We've flown it so many times and it's never fallen from the sky. Why does it do it over the stinky, muddy water? Maybe we got some good shots just before it died.
Now, what you might have noticed a problem with that video in that it was jittery. And one of the hottest developments now in the last few months, camera stabilizing gimbals. So this is a gyroscope that sits underneath the camera and motors which adjust for the motion of the quadcopter. So the quadcopter can be doing that, but your image is completely stable and the cinematic effects are amazing. Now, the full commercial cost of this is $15,000 to hold a RED camera. Another company has brought one out around the $1,000 mark. The hobbyists are selling this for $300. So when you start knocking zeros off the cost of things, and sometimes 2 zeros, amazing things are possible. The other problem you might have noticed was that it fell out of the sky, so we're working on that one.
That's a feature.
Yeah. It enabled this video. It really did. Yeah. So some of the technology enablers that are inherent in all of this, but really extend to a lot of things. The Raspberry Pi, you might have heard about that. It's a computer on a board. It has a processor. It can run an operating system, Linux. You can plug in a screen, keyboard, mouse, connect it to the network. And the most amazing thing about it is that it's $35. So it was built for education. It was built to teach kids how to make things. It also has input-output pins, so you can connect it to robotics, and we'll see a little bit more of that later. The other thing you might have heard of is the Arduino. And Arduino isn't a computer so much as it is a real-time input-output processing device. So it takes an input for the gyroscope. So the quad tilts this way, and it tells the motor to accelerate, to level it. And it does that in real time, which the Raspberry Pi doesn't do. The phone is the biggest enabler of all of this. All of your smartphones have gyroscopes, accelerometers, GPS units. And because of the mass production, it's driven the cost down to cents. And that is what is sitting in there. Something that's worth a few cents, but is enabling this. That's what a gyroscope looked like 5-10 years ago. And in today's dollars, it's about $17,000. Now it's cents. And that's what the gyroscope looks like on that board that I showed you. One of the other real accelerants of, I think, this makerspace is this. This is a Kickstarter project that's live right now. On top is an Arduino. On the bottom is a Wi-Fi card. So this is an internet-connected, tiny device that can sense its environment and do something. So, you know, whether it's sensing sunlight coming into the room and automatically putting the blinds down, or telling the internet that it's doing something, the applications are amazing. I'll talk about this a little later. Just notice on the right-hand side, and anytime you go on Kickstarter, have a look at how many backers/customers there are for a product and how overfunded something is. This is a movement. Something's happening here that is astonishing. $400,000 over a $10,000 goal. That's just amazing. Battery life will increase 3 magnitudes. That's 3 zeros. It's incredible. So the power as well as shortening the charging time. So you'll be able to charge your phone in seconds and it'll last an entire day. The community enablers. We talked a little bit about Kickstarter. I love watching people's behavior. I was in market research for a while and I've learned that it really doesn't matter what people tell you they're going to do versus what they actually do. And Kickstarter lets you see what people are doing with their wallets. And that's an incredible indicator of what's going on in the marketplace. So 1,600% overfunded. This combines Raspberry Pi and Arduino to make kits just easier to make. We saw the Spark Core. This is a little robot that someone put together. And this is another robot we'll see a little bit more of. But really, I urge you to pay attention to the overfunded projects. They're fascinating because they reveal a marketplace. This is where it all started for me. Back in November, the R10 quadricopter was put up on Kickstarter, and I thought, fantastic. I used to make things when I was a kid. And I had a business as a teenager making modems. And I haven't done that for 20, 25 years. So I thought, this would be great. I just need to assemble it. They've made all of the tough decisions for me. They've just started shipping now. But I'm very grateful to them because they forced me to go into the forums and buy a kit and realize that was too complex for me. So I went back to the quadcopter and now I'm learning to fly that. These guys, Tech Shop in the States, I think there are about 8 of these. They take a warehouse space, invest $1 million in capital machinery, so the latest 3D printers, laser cutters, CNC milling machines to cut out of aluminium and steel. They teach you how to use all of those tools, and you can access it for just $125 a month. Not only do they provide you a workshop, I think this is critical, they provide you with offices, co-working spaces, and a place to develop products with other people who are doing shit and making shit. This is where the Square credit card reader was made that fits into your phone, that is now revolutionizing how commerce is done for a lot of small businesses. I'd love to see some of these set up in Australia. And I love their motto, so dream it, build it. And the bigger opportunity that's coming up is the ability to manufacture it, because factories are starting to retool themselves around a concept called direct digital manufacture. And rapid prototyping is moving into manufacture as well. This is a beautiful example of 3D printing. This could only be developed through a 3D printing process. It's a proof of concept, but I think they're beautiful. They actually put LED lights inside, and as the music plays, it looks wonderful. This is the Tesla factory. So these German robots, KUKA I think they are, and what they allow Tesla to do is to have one brand of car in one slot and a totally different brand of car in the next one. And what they're doing is they're rejigging the production line through software. So imagine if you sent a prototype file, 3D CAD file, to a factory that's close to your customers. So it could be in China, could be in Sao Paulo, could be in England, in the US. They manufacture it because software makes it easy to retool, and then they deliver it locally. So less shipping costs, less time to market. I think this is quite revolutionary. This is starting to become that 90% of the pie. Here in Sydney, we've got some hacker spaces. Robots and Dinosaurs opens one weeknight and a weekend. These are guys that have some of these tools. They're the closest to a hacker space I found in Sydney. Ninja Blocks is an Australian company that invites you to hack together sensors and actuators so you can control your lights and start to program things through the internet. ProtoHub is in Oxford Street. They're making it easy for people to work together and have access to tools that you wouldn't necessarily have in your garage. And Osbury Pi is a great little community of people who are doing things and making shit and solving problems with the Raspberry Pi. That was their meeting yesterday. Now, I'd love to see some hacker spaces evolve out of this. Now, speaking of solving problems, I've discovered that I've got a new problem. This is Louis Seacat, and this is him not locked up in a room. This is him when you ignore him for 5 seconds. He is unbelievably, not starved, but he wants constant attention and interaction. Now, the way I propose to solve his need is to crowdsource his entertainment. So I'm launching catwaller.com, and it's live. Well, the sign-up page is live. And I think we can entertain him through the internet and with some internet-connected devices running on Arduino and Raspberry Pi. This is what it might look like. So you take a Raspberry Pi, you add something called a BrickPi, which is a current Kickstarter project, which has actuators for Lego blocks. So Lego has a thing called Mindstorms. And they put these two together in a frame where you can attach Lego bits to it. And then you get an internet-connected ball thrower. Now, combined with this, and Dan sort of stole my thunder a little bit.
Sorry.
That's all right. I want to create a button which has an Arduino Wi-Fi shield in it that's battery operated, which means I don't have to wire it to anything. So this is a button which actuates something on the internet. And what that is a Google Hangout with Louis. And so hopefully pretty soon, I'm pretty serious about this, I want to do it. Pretty soon,
I'm so tired of being alone. I'm so tired.
when we're not home,
Won't you help me, girl, just as soon as you can?
he can do that for an hour, no problem. So thank you very much. If you're interested in Make a Drone, it's live.